In October 2025, something extraordinary streaked across the Martian sky, moving faster than any known object. Perseverance's night sky cameras recorded a startling flash, traveling at 60 kilometers per second, perfectly timed with the historic flyby of interstellar visitor 3I Atlas. As if the universe itself were holding its breath, scheduled Mars orbiters went dark, and the raw images from the flyby vanished into silence. Almost immediately, reports, unverified and fragmentary, began to surface. Multiple fast-moving objects, sudden streaks across the sky, and a strange green flash that defied explanation. The initial frames hinted at behavior no comet had ever shown, with motion and emissions that contradicted every model scientists had trusted for decades. Yet official data releases stalled at the moment when clarity was most needed, leaving both professional astronomers and the global scientific community grasping for answers. What truly occurred in those missing frames? Were these anomalies simply artifacts or evidence of something far stranger? Could this fleeting glimpse force humanity to rethink everything we know about interstellar visitors and the rules that govern their passage through our solar system? The mystery endures, unresolved, teasing our understanding of the cosmos. If you're fascinated by this investigation, please like to help more curious minds find it. On October 2nd, 2025, amateur astronomer Stephen Burns posted a 9-minute time-lapse from Perseverance's raw image archive. The sequence revealed a single, razor-thin streak cutting across the Martian starscape at 60 kilometers per second. This speed far exceeded any known meteor, satellite, or cosmic ray artifact, and stood out because only interstellar objects typically move so fast at Mars's distance. Burns meticulously calibrated the frames against star catalogs, checked timestamps, and ruled out camera artifacts. The streak's motion was verified frame by frame, and he published the full stack for community replication. Tens of thousands of observers downloaded the frames, stacking them in various ways, debating whether the streak was real or an artifact. Burns stressed caution and external replication before leaping to conclusions. If the 60 kilometer per second measurement held, it matched 3I Atlas's predicted sky motion almost exactly. The amateur community rose to the challenge. Could anyone else reproduce this anomaly, or would it dissolve under scrutiny? Spot something we missed? Drop a comment with your replication results. Timestamps and methods help everyone. Online forums erupted once Burns's time-lapse went public. Hundreds of analysts rushed to download Perseverance frames to either replicate or disprove the streak. Some succeeded, claiming to see hints of secondary fast movers on October 3rd. Others saw only noise. Accusations of overfitting and artifact hunting flew back and forth. Then, at 0003 UTC, a brief green flash appeared in one group's animation. Was it a real emission event or a cosmic ray artifact amplified by stacking? Teams dissected the color channels, debating calibration and filter settings. Some argued the green flash was chemically plausible, possibly a cometary emission line. Others countered that Mars's thin atmosphere and camera quirks could create digital ghosts. Without raw, unprocessed images, every claim remained provisional. Statistical tests for signal-to-noise ratio, frame-to-frame consistency, and cosmic ray rejection became battlegrounds. The absence of rapid data releases deepened suspicion. Was this normal lag or something more deliberate, like deep dives into open data? Subscribe so you don't miss the follow-up when new frames drop. Mars offered a rare vantage on 3I Atlas in early October. 3 orbiters, MRO, HiRISE, ESA's TGO, CASSIS, and Mars Express, HRSC, targeted the visitor were 3.9 million kilometers away. Even HiRISE could only chase a smudge, so narrow fields were reprogrammed to track the predicted path. Too early and it missed. Too late and it blended into background stars. CASSIS planned multi-band shots for jets and fragments. HRSC swept wide. Teams balanced exposure, cosmic ray rejection, bandwidth, and JPL ephemeris updates. Normally, Mars orbiter data hits public archives within days, even uncalibrated. This time, nothing. No quick look frames, no preliminary stacks. Only cryptic status updates about calibration. JPL imaging teams faced a delicate balancing act. Moving targets at 60 kilometers per second break standard pipelines. Flat fielding, geometric correction, and radiometric calibration had to be reworked. Even cosmic ray rejection filters struggled to separate real interstellar streaks from stray charged particles. Every frame was checked for registration drift, anomalies flagged, flashes reviewed manually. The stakes were clear: released too early, and digital ghosts could ignite global frenzy; released too late, and accusations of cover-up multiply. Caution took precedence over speed. The next release would need to settle whether Mars cameras caught a single nucleus, a cluster of fragments, or a comet's green glow is usually straightforward. Dicarbon emits bright green when sunlight breaks molecular bonds. But 3I Atlas defied expectation. Reports claimed a fleeting green flash, yet early Mars Express and TGO spectra showed weak or missing C2 emissions. Instead, carbon dioxide dominated, water was nearly absent, and the chemical signature defied standard comet physics. Spectroscopists cautioned against premature interpretation, awaiting calibrated, time-locked spectra. Even metals were unusual. Nickel lines dominated over iron, a reversal of typical solar system comets. The anti-tail, sunward jets, and sharply defined plume geometry challenged dust models. Classical fan-shaped, tails were absent. Simulations suggested only a massive, dense nucleus could sustain such a plume. Non-gravitational acceleration was minimal, hinting at enormous mass. Every anomaly added to a growing dossier. Chemistry, dynamics, mass, and structure all stretched natural models. Avibay's team backtraced 3I Atlas's path, calculating a 0.6% chance of crossing the 1977 WOW signal's sky coordinates. The hydrogen line remains a key frequency for potential interstellar communication. SEI researchers warned of positional uncertainty and post hoc reasoning, yet the coincidence intrigued observers. After October 29th, 3I Atlas disappeared behind the sun for 5 weeks, blinding Earth and Mars-based instruments. Observers awaited December's return to track brightness, trajectory, tail morphology, and spectra. Verification would hinge on repeatability, multiband confirmation, geometric consistency, and structural evidence. Each anomaly climbs this ladder, with the burden of proof rising with each claim. 3I Atlas defies everything we know about comets. Its nickel-rich composition, carbon dioxide-dominated outgassing, and massive sunward plume are all unusual. Even more intriguing, its path briefly overlaps the 1977 WOW signal coordinates, though no independent radio detection has confirmed anything. As it moves toward perihelion and disappears behind the sun, observation is impossible, leaving scientists and amateur astronomers alike in suspense. Every frame, spectrum, and streak becomes crucial, yet nothing can fully explain its anomalies. Until the next data release, the interstellar visitor remains a puzzle, an array of strange signals, chemical surprises, and mysterious motion, waiting for careful analysis to reveal its secrets. If you want the full breakdown the moment new data lands, subscribe, like, and comment with the one question you want answered first.